I've checked, right? I've checked. The max load is given here, yeah, 2,800 amps. So on this particular cable, the max load is 2,800 amps. So based on the previous practice, we either use IS as 2,800 or 2,800 divided by 0.95, which is about 3,000 amp. So the past practice is that we choose the higher one. So in this case, we choose 3,000 amp. And then to ensure grading, okay, when considering the fault at bus A between relay 4 and relay 3, we have to first determine what is the reaction time of relay number 3 when we are considering fault level of 22.7 kA at bus A. So we take the extreme inverse curve because relay number 3 is considering extreme inverse curve. We take the extreme inverse curve of relay number 3 and put in the fault current into that equation, which is like this. And then we will obtain the reaction time of relay 3 when we are considering the fault at bus A. That is 0.085 seconds. Okay, this is the TMS and this is the IS of relay 3, all right, from the previous slide here. And then the accepted standard again is that every protection system should at least be 0.3 seconds apart. Okay, this is a standard that has been accepted. Okay, the grading of 0.3 second is to ensure that there's no overlapping, okay, of two protection systems operating at the same time. So 0.3 plus 0.085, which is the reaction time of relay 3, and 0.3 is to ensure grading, and equals to TMS multiply 0.14. Okay, this 0.14 is the constant for standard inverse because let's say that now in relay number 4, we are not using extreme inverse anymore. We are using standard inverse divided by the fault current divided by the IS that we have selected, which is 3,000, because we are getting from what we mentioned earlier, 2008 divided by 0.95. This is the ratio, and minus 1. And therefore, we get the TMS of 0.114 seconds. Right? So the TMS of relay number 4 is 0.14 seconds, and the IS is 3,000 amp. One correction that I wanted to point out here is the power over here. The power over here for standard inverse is 0.02. It's not 2 as written over here. Yeah, so please take note for standard inverse curve. So again, I repeat, in relay number 4, I'm using standard inverse curve just so that to demonstrate to you any curve can be used. But in this relay number 4, we use standard inverse curve. And TMS equals to, and from this standard inverse curve, we calculated our TMS to be this and our IS to be this. And one more point to let you know is that extreme inverse curve, normally, in most of the cases, right, extreme inverse curve perform faster than the standard inverse curve. So in the downstream of the network, we want it to perform faster. In the upstream of the network, we want it to perform slower because we want to trip the lower part of the network first before we trip the upper part. Because if you trip the upper part, for example, if you trip relay number 4, all the big chunk of the network below will be tripped off. We don't want that. We want to minimize our tripping. Therefore, the lower part of the network, we want it to perform faster. And as we go up the network, we want the relay to perform slower and slower and slower. So if the bottom part of the network you use extreme inverse, then it is okay that you use the standard inverse in the top part of the network. But if you use standard inverse at the lower part of the network, then it is not that acceptable. It's not that advisable that you use extreme inverse curve in the top part of the network because you might encounter the situation where the top part of the network will perform faster than the lower part of the network because extreme inverse curve generally perform faster than the standard inverse curve, although the TMS and the IS can affect the time. So general rule of thumb, the bottom part want it to be faster, the top part want to be slower. So extreme inverse curve is most of the time faster than a standard inverse curve. So to ensure, if you want to ensure that the grading is done properly, it's better that we use the same curve throughout the relay instead of mix of curve, right? So, but in this example, I'm just letting you know it is possible to have mixed usage of inverse curve. Okay, so this is the way, right? The strategy to perform grading, perform relay setting. So with this, we finish the protection system lecture, and in the next lecture series, I will talk to you about distribution protection, reliability of the distribution system, and power system in general.